In this video, I will show you how to factor polynomials such as these. We will be using the box method, the grouping method, and possibly the difference of two squares, and of course we'll be factoring out the GCF. Notice that these polynomials are degree 4. Alright, I see the fourth power in here, and that's going to represent no trouble at all. Number 7 is just a binomial, so I'm not going to do the box method or grouping. All that's going to come later. Step 1 is always greatest common factor, GCF. I'm noticing that both of these are divisible by 2, and I notice that both terms have a's in them. So how many a's will I pull out? I will pull out a squared, because that's the lower amount. You always pull out the lower amount. Now, I'm going to have some parentheses happening now. But to figure out what goes inside the parentheses, I need to divide by the GCF. So I'm going to divide by 2a squared, both terms. So inside of the parentheses, the 2's cancel out. A to the fourth power divided by a squared is going to be a squared. 16 divided by 2 is 8. And the a squares cancel each other out. So this is what I have so far. Now I should look very carefully to see if I can keep going. But I cannot. This is the sum of, well, I started to say the sum of two squares. 8 is not a perfect square like 4 or 9 or 16 or 25. And even if it was, even if this was a squared plus 9, I still couldn't factor it. It has to be the difference of two squares. It has to be subtraction. So no matter how you look at it, this problem is done. GCF is all you can do. When I see a trinomial like this, I'm either going to do grouping or I'm going to do the box method, which are really different versions of the same thing. For this particular problem, I'm going to do grouping. On another problem, I will show you the box method. Either way, the first step is to look for a common factor. Now, the last term has no variables. However, all terms are divisible by 2. So that means I'm going to have a GCF of 2. So I am going to pull that out, and then I'm going to divide everything by 2. So that's going to give me a to the fourth power minus 19 a squared plus 90. Next, we need a product and a sum. So I'm going to set up my product and my sum. Let's start with the product. The product comes from A times C. 1 times 90, so that's going to be 90. The sum comes from the B value, so that's got to be negative 19. So next I'm going to take the product and I'm going to make a list of all of the ways I can make that product. Now I feel like I could do a pretty good job of doing this just from my head. However, this number is sufficiently big that now would be a good time to show you the calculator trick. I can use the calculator to generate my list by hitting the table button. Let's clear out anything in there. Take the number that you're trying to factor. I want all of the things that multiply together to give me 90. So I'm going to take that 90 and I'm going to divide by x and hit enter. I want to start at 1. Okay, and this should be an auto, not ask mode. Alright, and it really just basically gives you the list right here. So let me just jump over here. So I've got 1 times 90, and I've got 2 times 45, and I've got 3 times 30. Okay, all of those are right on the screen. Let me scroll down some more. Alright, 4 is a decimal, so that won't be on the list. But then I've got 5 times 18 and 6 times 15. Alright, so I'm just going to scroll down. 7 is a decimal, 8 gives us a decimal, and then 9 times 10, of course. So that's how you can use your calculator to generate the complete list. Now, which one of these pairs can give me a sum of negative 19 if I pick the signs right? Well, turns out to be the obvious one. 90, the first thing that probably pops into your head is 9 times 10. So, okay, in this case, we probably didn't need the whole list, but it's a good habit to get yourself into. But this is the pair that will make negative 19. If I pick the signs right, meaning I would need a negative 9 and a negative 10 to add up to negative 19. Then I have to use the same numbers for the product. Negative 9 times negative 10 is positive 90, so we're good. Now, for the grouping method, so please remember, we're not looking at this anymore. Alright, now we're just looking at the red trinomial. So start with the first term and just bring that straight down. So I'm going to bring down my a to the 4th power. Okay, look at the last term. I'm just going to bring that straight down. So you see that plus 90? I'm just bringing that straight down. Now the middle term is negative 19a squared. What I'm going to do is I'm going to take the middle term and I'm going to split it up using these two numbers that I just found. So instead of writing negative 19a squared, I'm going to write negative 9a squared and negative 10a squared. I'm just splitting it apart. It's still the same thing. If I combined like terms, it would go right back to negative 19a squared again. So I haven't changed anything. But in this form, what I can do is I can do the greatest common factor of the first pair and the greatest common factor of the second pair. So if I do that, the GCF of the first pair is going to be a squared. And the GCF of the second pair is going to be negative 10. Okay, obviously both of these are divisible by 10, but if the first term is negative, then your GCF is negative. All right, now let's talk about what goes inside the parentheses. Well, you have to divide by your GCF. So I'm dividing by a squared right here. And I'm dividing by negative 10 right here. So what is that going to give us? Well, a to the 4th power divided by a squared is a squared. These a squares will cancel each other out, and that's just going to leave me with negative 9. So I have a squared minus 9. Now, these negative 10s are going to cancel each other out, and that's just going to leave me with a squared. And 90 divided by negative 10 is negative 9. Notice how the parentheses are the same. For the grouping method, that should always happen. If these parentheses are not the same, you made a mistake, go back and look for what you did wrong. Now, because these are the same, they are a common factor. So anytime you have a common factor, you want to bring it out front. So I'm going to take this a squared minus 9. All right, both of them will combine into 1 in the front. I don't square this, just bring them both out front as 1. And then if I take those away, what does that leave behind? Well, it leaves these blue terms behind. It's going to leave behind the a squared and the minus 10. So a squared minus 10. Okay, so sometimes I would be finished right now, but not in this particular case. Mostly because a squared minus 9 is the difference of squares. So you really have to watch out for that. So we're going to have to keep going. So this will factor further using the difference of squares pattern. Alright, a squared minus 9 will factor as a plus 3 times a minus 3. Alright, that's how you factor the difference of squares. Now, can I also factor the a squared minus 10? Is this going to be a plus 5, a minus 5? No, that would be 25. 10 is not a perfect square. So this is not the difference of squares, so it's unfactorable. So I'm just going to leave this as a squared minus 10. Now this is almost the final answer. The only thing that's missing is right at the beginning we factored out a GCF of 2. That 2 is really still there, so we need to be sure to include it in the final answer. So this is the final answer. For number 9, we've got this trinomial. So I'm either going to factor using the box method or I'm going to do grouping. On the last problem I did grouping, so this time I'm going to use the box method. First I look for a common factor. There is no common factor. So I'm going to move on to the part where I find a product and a sum. The product has to be A times C, 1 times 30. So the product is going to be 30. The sum has to be the B value, so that's going to be 13. Now I'm going to make a little list over here based on the product. Okay, I need all of the things that multiply together that give me 30, and I'm going to put them in order. So this could be 1 times 30, or 2 times 15, or 3 times 10, or 5 times 6. These are all of the ways to make 30. Now, which pair of numbers will make a sum of 13 if I pick the signs right? So be careful, there are actually 2. I can make a 13 out of 2 and 15 if I have a negative 2 and a positive 15. Or I can make a 13 out of 3 and 10, or if I just leave them both positive. Okay, considering the fact that I don't see any negative signs anywhere, it's a safe bet that I'm going to end up using the 3 and the 10. So let's just go straight to that, but if it doesn't work out, I've still got the 2 and 15 to play around with. So 3 and 10. I can just leave them positive and it makes 13. I have to use the exact same numbers for the product, so 3 times 10. And that's also positive 30, so boom, that's the pair that is going to work. Okay, so we're doing the box method, so it's time to draw the box. Alright, in the first square, we put the first term, which is m to the 4th power. In the last square goes the last term, which is 30. In the other two squares, we put the two numbers that we just found, but the variable part has to match the middle term, because really we are splitting up the middle term. So I'm going to take the 3 and I'm going to write 3m squared. Okay, again, m squared because of the middle term is m squared. And because of the 10, I'm going to put 10m squared. So after that, you should do the GCF of every row and every column. The GCF of the top row is going to be m squared. The GCF of the bottom row is 3. All right, plus 3. The GCF of the first column is m squared. The GCF of the second column is 10. All right, so these purple numbers will give me a binomial times a binomial. So here I have m squared plus 3 times m squared plus 10. Okay, now I should always look to see if there's anything I can factor further. I don't see the difference of squares or anything, so this is it. Also, I should check, did I pull out a GCF that I need to bring down? No, there was no GCF, so that means this is actually the final answer. Okay, here's another trinomial. So we either do the box method or the grouping method. So on the last problem we did the box method, so this time I'm going to do grouping. First we look and see, is there a common factor? Nope, there's no common factor. So then I move on to finding a product and a sum involving the same numbers. The product has to be A times C. 1 times -8 is -8. The sum has to be the B value, so that's 2. So now I will come over here and make a little list for myself based on the product. So here's my little list. Okay, so my product is 8. What are all the ways I can multiply and get 8? Let's write them in order. 1 times 8, 2 times 4, and that's it. That's the end of the list. That was my alarm that tells me that it's time to turn off the Wi-Fi for the kids. It's time for them to get ready for bed. I'm such a mean dad turning off the internet. Anyway, which pair of these will make a sum of 2? Well, that's going to be the 2 and the 4 pair. Okay, so if I do 2 and 4, well, that would make 6. To make a positive 2, I need a -2 and positive 4. And I need to use the exact same numbers for the product. And luckily, -2 times positive 4 is -8, so that's great. Now, for the grouping method, I take the first term and I bring it straight down. So I'm going to have m to the 4th power. I take the last term and I bring it straight down. So there's my -8. Now, instead of bringing the middle term straight down, I actually need to split the middle term up, okay, into 2 different terms using these numbers that I just found. So I'm going to take 2m squared and I'm going to split it up as -2m squared, see the -2, plus 4m squared because of the 4. And look, if I combine like terms, it makes 2m squared, so I haven't changed anything. So next we will find the GCF of the first 2 terms, and we will find the GCF of the second 2 terms. So the GCF of the first 2 terms is m squared. So I've got m squared in the front. The GCF of the second 2 terms is 4. So I'm going to put plus 4. Okay. Now, I'm going to have some parentheses, and to figure out what goes inside of the parentheses, I need to divide by the GCF. So I'm going to divide by m squared, and I will divide by 4. Okay, this will tell me what to put inside the parentheses. Okay, so m to the 4th power divided by m squared is m squared. And then I'm going to have minus The m squares cancel out, but I still have the 2. So I have m squared minus 2. And then meanwhile, over here, the 4's cancel out, and that's going to leave m squared. And negative 8 divided by 4 is negative 2. Notice that the parentheses are the same, m squared minus 2. For the grouping method, these should always be the same. If they're not the same, you made a mistake. You need to go back and check your steps. Now, because these are the same, they are actually a common factor. And we're going to do what we always do with a GCF and put it way out in the front. So I'm going to take my m squared minus 2 and put it out front. Now if I take those away, that's going to leave behind these blue terms. It's going to leave behind m squared plus 4. Okay, so we have now factored. The only question is, will it factor any further? Can either of these be factored more? And specifically, look for, are either of these the difference of two squares? The blue one is not, because it is addition, so that's not the difference of anything. The purple one is not, because 2 is not a perfect square. If I had m squared minus 4, then I could keep going and do m plus 2, m minus 2. But considering what we have, this is going to be the final answer. So as soon as I see this trinomial, I'm thinking, we're either going to do the box method or the grouping method. Since I did grouping on the last problem, I'm going to do the box method on this problem. Okay, I scanned for a common factor. There is no common factor. So I'm going to go ahead and come up with a product and a sum involving the same two numbers. But the product has to be A times C. That's 1 times 80. So there's my product. The sum has to be the B value. So that's going to be negative 18. So next I'm going to take that product and I'm going to make a list for it off to the side. Now I could probably make this list just using my brain, but it's just big enough that I think it might be useful to use the calculator and show you the calculator trick. So remember, the calculator trick is hit the table button and take the number that you're trying to factor in different ways and type that in. So we will do 80 and then divided by x, and then just hit enter. I like to just start at 1, okay, and just keep hitting enter till you get to the table. So basically they're giving you the very table that we need to write down. So I see 1 times 80, 2 times 40, okay, 3 is giving me a decimal, so that's not going to be on the list. Okay, and then I've got 4 times 20, 5 times 16. Six is a decimal. 7's a decimal. I've got 8 times 10. And 9 was a decimal. So this is the complete list. Now, which pair of these can make a sum of negative 18 if I pick the signs right? Well, this pair will make negative 18 if I pick the signs right. Alright, so fine, I'm going to have an 8 and a 10. But if I want negative 18, I need a negative 8 and a negative 10. Then I have to use the same exact numbers for the product. So negative 8 times negative 10 is positive 80. So everything is working out great. time to draw the box. Okay, the first term goes in the first square. So I'm just going to write x to the fourth power. The last term goes in the last square, so 80 goes here. In the other two squares, I'm going to use the two numbers that we just found. But what I'm really doing is I'm splitting up the middle term, negative 18x squared. I'm splitting it up into two terms. So that's why I'm going to use x squared. So I'm going to do negative 8x squared, and I'm going to do negative 10x squared. So next we want to find the GCF of every row and every column. The GCF of the top row is x squared. The GCF of the bottom row is negative 8. Obviously both of these are divisible by 8. The reason why I put negative 8 is because the first term is negative. Okay, the GCF of the first column is x squared. And the GCF of the second column is negative 10. Again, they're both divisible by 10. I put negative because the first term is negative. So these purple terms will give me a binomial times a binomial. So I'm going to have x squared minus 8, you see that on the left, times x squared minus 10 from the top. Now, before I call this the final answer, I just double check and make sure that neither one of these is the difference of two squares. These are both differences. However, neither 8 nor 10 is a perfect square. So these cannot be factored any further. So this is the final answer. Alright, let's just do one more problem on this video. I see that we have a trinomial, so that means either the box method or grouping. Since we did the box method on the last problem, let's go ahead and try grouping on this problem. Okay, so first we look and see, is there a common factor? I'm pretty sure that all of these are divisible by 6. So let's try that out. I'm pretty sure 6 is the common factor. Alright, so if I pull out a 6, which means, of course, I'm dividing everything by 6. Alright, so that means I'm going to have m to the fourth power minus 12m squared. And let's see, 210 divided by 6 is 35. Okay, so for the rest of the problem, I'm not going to be looking at this anymore. Now I'm looking at this red trinomial. Okay, so we're doing grouping. So for grouping, I'm going to need a product and a sum. The product has to be A times C, 1 times 35. So that's the product's going to be 35. The sum has to be the B value, so that's going to be negative 12. Now, focus on the product for a minute. I'm going to come off to the side and I'm going to make a little list of all of the things that will multiply together and give me this product. Starting with 1. So 1 times 35 and 5 times 7. I feel like I'm leaving something out. Maybe that's it. Well, which pair of numbers can give me a sum of negative 12? Obviously, it's going to be the 5 and the 7. However, to make a negative 12, I would need a negative 5 and a negative 7. I have to use the exact same numbers for the product. So negative 5 times negative 7 is positive 35, so that's working out great. So for the grouping method, what you want to do is take your first term and bring it straight down. So I have m to the 4th power. And then take your last term and bring it straight down. So that's going to be 35. I'll say plus 35. Now, for the middle term, instead of just bringing the middle term straight down, I actually need to take the middle term and split it up into two terms using the two numbers that I just found. So that's why I'm going to write negative 5m squared and negative 7m squared. Now I'm going to find the GCF of each pair of numbers. So I'm going to find the GCF of the first two, and I'm going to find the GCF of the second two. Okay, so the GCF of the first two is going to be m squared. And then I'm going to have something inside of parentheses, and I'll come back to that in a minute. The GCF of the second pair is going to be negative 7. And then I'm going to have something inside of parentheses. Obviously, both of these are divisible by 7. I'm putting negative 7 because the first term is negative. So, to figure out what goes inside the parentheses, you need to divide by your GCF. So I'm going to divide these by m squared, and I'm going to divide these by negative 7. Alright, that's going to give me m squared minus 5. And over here, I'm going to have m squared minus 5. Notice that the parentheses are the same. For the grouping method, the parentheses should always be the same. If they're not, you made a mistake and you need to go back through your steps. Because these are the same, that means that m squared minus 5 is a common factor. And when you have a common factor, you pull it out to the front. If I take away the m squared minus 5's, that will leave behind the blue terms. That's going to leave behind m squared minus 7. Now I'm going to glance at this to see if I can factor further. Are either of these the difference of two squares? No, neither 5 nor 7 is a perfect square. That means this is the final answer. Whoa! Almost made a mistake. On this particular problem, at the very beginning, we pulled out a common factor of 6. Now, that 6 needs not to disappear. So it should be included in your final answer. So this 6 is going to be there. So this is the final answer. Phew! I hate it when I make mistakes. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.